Hello, ladies and gentlemen, in my life science class. Mr. Escox coming back to you. We're starting the second section on dominant and recessive and predicting crosses. In your chapter 4, we did Mendels genetics in chapter 4, section 1. Now we're moving on and how we've come up with these things called Punnett squares and how we predict genetic crosses and why they'll be useful for humans in the future and today. Dominant and recessive human traits. Dominant trait, dark hair. Recessive trait, light hair. Dominant trait can be A or B blood. Recessive trait, O blood. Tongue ruler, dominant, non-tongue ruler, recessive. We can predict our patterns of heredity by using what we call a Punnett square. This is a Punnett square from your book. In the book, they use D's instead of T's. I was brought up more with the T's. So all you really have to do, D, capital is dominant. So this is dominant regular height. Dominant regular height. Dwarf, dwarf. So you bring one down, D, bring one over, little d. Bring one down, bring it over. Down, over, down, over. You always write the dominant first. All of these are heterozygous. Dominant. The parents, this one was what we called homozygous. Dominant. And the other parent, right here, this one was homozygous, recessive. So we'll watch this video in class about the fur color of rabbits, but we're going to work it out together too, just for some practice. So they have homozygous recessive for white fur on top, and homozygous dominant for black fur on the side. Well, when you bring it over, you get dominant, recessive, dominant, recessive, dominant, recessive, dominant, recessive. In this case, that is a 4-to-0 ratio. All right, let's try one with some of Mendel's pea plants here. If I cross heterozygous, tall, this is basically the middle second cross. And both of them are heterozygous, tall. We set up our Punnett square. You put one parent on top, and you make sure you segregate the alleles. You put the other parent on the side. Do not cross these up. And when you're doing Punnett squares, you need to be very careful that you're writing good capitals and good lowercase letters because some graders get in trouble with sloppy handwriting. You bring it over, this is tall. This one is heterozygous tall. This one's going to be heterozygous tall. And then this one will be homozygous recessive. Tall, 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 and short. My ratio here is 3 talls to 1 short. What happens if I take a heterozygous tall and I cross that with homozygous short? So you end up with a heterozygous tall. You end up with another heterozygous tall. This one would be short, and this one would be short. Oh, by the way, tall and short are your phenotypes here. So this one has a ratio of 2 to 2, but we reduce that down to 1 to 1. 1 tall to 1 short. If you want to make this a probability, 3 to 1, well, 3/4 of 1 is 75%. If I want to make 1 to 1 a probability, that one is 50%. Here's a good joke for you. These are heterozygotes. Heterozygote means you have one black and one white, although very rarely would you see something like that. Probability is the fraction of time an event should occur. We can use probability to predict the results of crosses, or it could be as simple as just flipping a coin. You flip a coin, you have 50% chance of getting heads, 50% chance of getting tails. Probability is generally can be either as a ratio or a percent. A ratio takes how many of one type of genotype compared to the other, or you can do phenotypic ratio where you do like brown hairs to blonde hairs. Or in the percentage, you're comparing a ratio to 100. So like if you got 48 out of 50, you actually got a 96% out of 100. The Punnett Square is not definite, although like say, if you don't have any red hair genes, your baby will not have red hair. Speaking of red hair, let's do one more Punnett Square, and we'll talk a little bit about the red hair gene because it's kind of interesting, and I do have some family with red hair. So if you have dark hair, but you carry the red hair gene, they usually use lowercase b with an R for red. So that's heterozygous dark hair, the blonde recessive. And I cross that with blonde hair that carries a red gene. Now this is actually a cross directly from my family. Not my personal family, but my brother's family. So here you have dark hair, and when we cross the dark hair, you segregate the alleles, capital B, lowercase b, with an R, and you cross that with the blonde, that carries the red gene. You have this offspring would have dark hair. This offspring here would have blonde hair, but be a carrier of the red gene. This offspring here would have dark hair and carry the red hair gene. And last but not least, I have two red-headed nephews. And the only way to have red hair is to be homozygous red. All right, ladies and gentlemen, that takes me to the end of that lesson. We'll be doing a lot more. So if you did your ratios here, I mean, literally you have a 50% chance of brown. You have 25% blonde. Pen's not working very good. And 25% chance of having a redhead. It's just not letting me write. All right, ladies and gentlemen, until next time, be good, be safe. Mr. Hescock signing off.